All right, all right. Hello, everyone. Thank you so much for coming. Huge crowd today. Love to see it. Uh, I'm Noah. I will be your one of your guest lectures today. This is Shungo. We're going to introduce ourselves a bit more in a second. But before that, we do have a few announcements. So today's lecture is going to be about images. We'll talk more about that in a little bit. But like I said, a few quick announcements. PA6 is due tonight. Make sure you get that uploaded to CMS. And then today is unfortunately the last day of this class. Very sad. You'll never see our faces again. Just kidding. Hopefully we see you again. But today's the last day. So thank you so much for making it through this semester. It was great having you guys on behalf of the course instructors who actually had you over the past few weeks. So, like I said, I'm Noah. I am the current team lead of app dev. Way back when I was a backend developer and I took this same course. I was in these seats, but it was virtual for me because I took it during COVID. And I always wanted to be a course instructor, but I never did it. And so I decided, I told Tony and Kidus, I said, you know what? As your president, I'm making you let me be a course instructor for the final lecture. So I decided to give a guest lecture and they let me do it, which was very nice of them. And also I brought along Shungo, one of my best friends, also from Backend, also on app dev. He graduated from app dev last semester, but he is still sticking around. He's like a fifth year super senior, wrapping up some credit. No, I'm just kidding. He's doing MEng. So yeah, anyways, I'm team lead. I'm in class of 2024. Do you want to introduce yourself real quick?
Yeah, I'm Shungo. I, just like Noah, was in your seats just, a couple of years ago. And I was on backend for a really long time. I actually taught this course for 2 semesters and then or went up to become the backend lead of the project team. I'm a little bit, underneath Noah in our in our club, so that's why I'm dressed a little bit less formally than him. And he's looking very spiffy. But yeah, excited to teach you guys today.
Yes, very excited. I'm dressed up because I was coming from another event, but I also wanted to dress up for you guys. So, anyways, let's move on. Today we're going to talk about images, and the more abstract concept that we're talking about here is storing data. And so you might remember, this is kind of like the structure that we've been looking at up to this point in the semester when it comes to a database. So we have, our primary key, some type of ID. We probably have a name for this object is like fruits, right? So we have the name, the type of fruit. We'll have a quantity. So this is going to be a number. And we'll have a price. So another number. And up until this point, these are kind of the only types that we've seen. So we've seen textual data types. We've seen integers, real numbers, or floats. But we haven't really talked about other data types that are very important and relevant in the real CS world. And so one of those types that we're going to talk about today is images. And this is something that you can implement in the hack challenge. I believe you have to either use authentication or images as like a bonus thing. So if you didn't like the authentication lecture from Monday, then today is your day to pay attention and take some notes. But is that true? No, that's not true. Okay. Ignore what I just said, but you should still pay attention today. I promise it's super interesting and helpful. So what we want to do is we have these pictures right here, and we want to somehow connect them with the rest of our data, right? And you might think that's super easy, but in reality, it's not. And the reason that is because there's a couple different ways of doing it with various trade-offs. So the first way that we can store images is using blobs in our database. Does anyone here know what a blob is? No? Okay, that's okay. So blob stands for binary large object. That's all it is. It's just a bunch of zeros and ones to represent any large object of data. So it could be an image, it could be a PDF, a document, it could be a bunch of text. It's just a way of storing any of these types of objects as just a bunch of zeros and ones. So that's the first way, is just storing those zeros and ones in our database. The second way, and we'll talk more about these in a second, but the second way is going to be a local file path of where that image is on our server and storing that file path in the database. The third way is going to be uploading our images to a cloud service and storing that URL in our database. So like I said, I'll talk more about these, but we're going to start off with storing blobs and how that works. So like I said, blob is a binary large object. And so what it looks like is just a bunch of gibberish. You and I can't understand it, but the computer will know, okay, this is binary. We're going to read it. We're going to interpret it into an image. And so essentially, we just take this image exactly how it's encoded in binary, and we just throw it in our database. We make a textual column for it and we put it there. And so, like I said, yeah, binary large objects is a collection of binary data, and you can use it for pretty much any type of file. So whether it's images, PDFs, other documents, anything like that. So it's nice because it's very versatile. And so, like I said, this is kind of what it might look like. Obviously, we have no clue what this image would be, right? It's just a bunch of gibberish, but it's a bunch of binary, and this is kind of how it's stored and recognized in the computer. So let's talk about pros and cons of binary large objects. The number one pro, and actually the only pro, is that it's very easy to implement. But there are a bunch of drawbacks, which we'll talk about in a second. And so essentially, as you can imagine, an image is, a pretty large piece of data. We have hundreds of pixels in both directions. That's thousands or maybe even tens of thousands of pixels, sometimes even millions of pixels when you have really large images. And we think about like other types of files like videos, PDFs, large documents. Those are much, much bigger. And so when we have to encode the binary of each individual pixel, we have to take all of that and dump it into our database. That's a lot of information. And databases already are pretty expensive to store information because they're very fast and they're backed up multiple times, which you'll see in this third point. It's slow to back up these databases when we throw that much information in them. And databases were also not designed for this type of thing. They weren't designed to hold files or to hold binary objects. They're designed for very simple textual information, like numbers, like text, and very simple rows. And so, yes, this is a possible way of doing it, but it's not the best way. So we're going to talk about a few of the other ways of doing this. So no binary large objects, don't do that, but you should know what it is. Number two is going to be storing images locally and then storing that file path in our database. So you might remember anytime you're coding up your app, you have like your app.py and your db.py, right? So you always have a server which is running on a computer somewhere, and then you have your database. And so this approach is essentially going to be uploading that file to your server and then keeping track of that file path and putting that path in your database. And so it describes exactly where that image is or whatever that file might be in your database, or sorry, in your server. And then we're taking that path and putting it into our database. And so you can either have relative or absolute paths. If you don't know what those are, that's completely okay. Essentially, a relative path is relative to some folder already in the server. So for example, here we have our app, which has a source and a static folder, and this Pikachu image. A relative file path would be relative to the static directory right here, whereas the absolute file path would be relative to the root directory. So on my computer, that starts at /user/Noah Solomon. On a server, it might be /root or something else. This is just something to be aware of when you're dealing with file paths, is whether or not you're using a relative or an absolute path. And so what we can do is then take that path and put it into our database. So let's talk about that. Data can exist outside of your database, which is what I was just kind of saying. Images are files. The same exact way that you have a computer, you can upload files to your computer. You can do the same thing with the server. And so if we have a static upload folder, we can create a route that will access the files from a post request and put those files into our server. And we'll talk more about exactly what that looks like later on. But we don't have to go into like the super specifics of how this will be implemented, but just know that if you're sending a post request, you could put a file in there and then you could read that file later on from your server. And so, for example, if we had our app, which up until this point, we've been dealing with just a source directory, we would also want to add an images directory or maybe uploads or files or something like that. And that's where we would dump all of these files. So once we do that, then we take that relative file path, so /images/apple.png, and we're just going to dump that short piece of text into our database. So as you can see, that's much, much simpler than putting the entire binary representation of that file, because all we need is a few characters representing where the file is on the actual server. All good so far? Any questions? Cool. So some benefits of this approach is that it's much, much faster than the binary large object approach, because we're not actually storing the files in the database itself. We don't need any special coding or pre-processing because all computers work the same way. You upload files to them and you have a file path for those files, and we put that path somewhere in our database, right? Image backup is asynchronous because these servers are already backed up And like when you use a server through AWS or DigitalOcean or something like that, they already take care of making sure if your server fails, there's another replica of that server with all the same files. So it looks like nothing actually happened. It's also much prettier. Obviously, we don't have to deal with that binary representation that we talked about before. But storing these large volumes of images directly on the server is not the best way of doing things, because it combines everything you're trying to do into one spot, right? Like we have our code living in the same spot as our files themselves, but we don't want to have all these things in the same place. Also, the access to the files depends on that server. So the files are living in the same place that we're deploying our code. And if the server crashes and it's not replicated, like I mentioned earlier, then we lose all those files, and that's not good either. So you might recall earlier this semester, we talked about clustering. In general, and not just in backend, but software engineering in general, you want to kind of reduce the amount of things you have relying on one fault line, right? So what do I mean by that is we want to separate our responsibilities of various functions into various places. And so if we have our server running our code in one place, we don't want that to also be dealing with our files and our images in the same spot. The same way that our database is not directly on that server, it's a separate process. So we use Postgres or SQL or something like that, SQLite. And that keeps everything separate, because if one thing fails, it means everything doesn't fail. We just have to fix that one thing that failed. So let's talk about the third approach, which you can imagine, process of elimination. Noah didn't like the other two. This is probably the best one, and you'd be exactly right if that's what you thought. So the third approach is storing the actual image full URL in our database. And what does that mean? Well, a URL is just a address on the internet somewhere that points to that image. And you've definitely seen one of these before. It'd be like google.com/logo.png, right? And so what we're going to do is we're going to take our image, we're going to send it into a cloud storage. So something like Amazon S3 you might have heard of, Microsoft Azure, Blob Storage, Google Cloud Storage. These are all very big companies that have already figured out the best way to do this. So we just say, you know what? You figured it out. We're not going to try to beat you. We're going to give you our images. We'll pay you maybe a few cents. You'll take care of putting it somewhere, storing it the right way, making sure it's replicated so that the server crashes, something bad happens. We have a copy of it. And then they just give us back a URL that we can then store in our database. And so they already have all the infrastructure. They have data centers all across the country to make sure that when I try to get that image, it's very quick, right? If I'm here in New York, it doesn't try to access a server on the West Coast. It's going to give me a server here on the East Coast from an East Coast data center. They already figured all that out. So we're not going to try to do it again. Why do we want to reinvent the wheel, right? And so all they're going to do is give us a URL that is essentially an abstraction to where that image is anywhere in the country in a different CDN or a different data center. And it's much, much easier than the previous two solutions that we talked about. And it's much more robust than anything that we could try to make with a very small budget. So what this looks like, and I briefly mentioned this, but the client typically sends a request to our app, right? We've seen this is what we've been doing all semester. Then our app is going to make another request to something like AWS S3 or another cloud service. So that request is going to contain that image. We're going to send it off to that service, and that service is going to send us back an image URL. Then we're going to take that image URL and we're going to store it in our database. So the same way that we stored those relative file paths for when we had images locally on our server, it's pretty much the same thing, except for now you'll see it is a fully qualified URL. So for example, this is http://mybucket.s3.com, blah, 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 blah. It'll probably be a very long URL. You don't have to understand exactly what all the subdomains and what everything really means, but they're just going to give you a URL that points to that image, and we're going to put that in our server. So very similar benefits as the last approach of local files, in that it's very simple to just store this URL. It's just a piece of text. We can very easily and cheaply store it in our database, but we also are able to take advantage of the super scalable and reliable infrastructure that has been implemented by companies like Amazon, companies like Microsoft. We're not going to reinvent the wheel because they already did it. And so if our app crashes or the server breaks or something happens, it's that separation of responsibilities, right? Because our images aren't stored on the server anyways. So we could literally break the server. We could, destroy it. We could burn it. We can start a new one. And our images are already somewhere else. They're up in the cloud. We don't have to worry about them being lost. We can also access every file by their URL. And what that means is that we don't have to go into the server to look at the images that have been uploaded. We can just grab that URL from our database and just put it in any regular old web browser and check it out. So that is the approach that we will be demoing today. And if I didn't miss anything, hopefully Shungo is able to fully show you guys how that works and what that looks like. Yeah, so I'm gonna hand off the microphone and give you the HDMI cable.